All right, guys, so let's look at the study guide, page 1. Number 1 says an aircraft has a total of 200 seats. Only 50 seats were occupied during a certain flight. What was the ratio of the number of seats that were occupied to the number of seats that were not occupied during the flight? And then it gives us the hint here to be sure to simplify our answer. All right. So there are a couple key pieces of information. Only 50 seats were occupied. That's important. And it had a total of 200 seats. So it wants to know the ratio of the number of seats that were occupied. So I know that that's 50. And I am going to compare that to the number of seats that were not. Well, if I had a total of 200 seats and 50 of them were occupied, I'm going to see what the difference is. So that means 150 seats were not occupied. So my ratio is 50 to 100. Or it can be written as a fraction, but I'm not done yet because it says to make sure I simplify my answer. So I have to find out what is the greatest common factor between 50 and 150. That means the biggest number that can go into 50 and it can go into 150. And if you remember, I gave you guys a little tip and I said to always look and see if the numerator can go into the denominator evenly, because then you found your greatest common factor. So in this case, 50 can indeed go into 150. So now I'm asking myself, how many 50s can I get out of 50? I could just get one. And then I'm asking myself, how many 50s can I get out of 150? And I can get 3. All right. So my final answer is a 1 to 3 ratio. Okay. Number 2, if the ratio of boys to girls in the 6th grade chorus is 3 to 5, which choice shows possible numbers of the boys and girls in the chorus? So this is asking us for equivalent ratios. So remember, the key piece of information here is that our ratio is 3 to 5. So I'm going to look at A. A tells me, first I'm going to compare that to my ratio of 3 to 5. And A tells me that there are 18 boys and 35 girls. So remember, whatever I do to one part of the ratio, I have to do to the other. So down here, I'm going from 5 to 35 by multiplying by 7. So that means up here, I need to also multiply by 7. And 3 times 7 is not 18. 3 times 7 is not 18. So that is not the one. Let's look at another one. Let's look at B. All right, B, remember again, we're comparing our ratio of 3 to 5. B has 15 boys and 25 girls. All right, so down here, I'm going from 5 to 25 by multiplying by 5. So that means up here, I need to also multiply by 5. And 3 times 5 is indeed 15. All right, so it only says which choice, so I'm only choosing one, and I already found it. That's B. Now, if B wasn't in, I would continue, and I would do this same method to see which one of these was an equivalent ratio to 3 to 5. All right, let's look at number 3. In a small group of ducks, there are 8 males and 3 females. Which ratio of males to females is an equivalent ratio? So again, we are comparing our 8 to 3. So let's look at A. All right, so we are comparing this 8 to 3 equivalent ratios, and the first one is 16 to 9. So I need to see if whatever's happening to one part is happening to the other. So I go from 3 to 9 by multiplying by 3. But if I multiplied up here by 3, 8 times 3 is not 16. So it's not A. Let's look at B. Again, I'm comparing my 8 to 3 to the ratio they give me of 4 to 3. I'm going from 3 to 3 by multiplying by 1. And 8 times 1 is not 4. So it's not B. Let's look at C. Again, my ratio of 8 to 3. And this has a ratio of 6 to 16. And when I go from 3 to 16, I am going up. It's not an easy jump there, but I am multiplying up. Let's see, when I look at 3 going up to 16, 8 going down to 6 can't possibly be doing the same thing. So I know that C is wrong. So I know by process of elimination that it's D, but let's go ahead and look at it and check the math. 8 to 3 equal to the ratio of 24 to 9. 3 goes to 9 by multiplying by 3. And that means I have to multiply by 3 up here as well. And 8 times 3 is indeed 24. So my answer is D. All right, let's look at number 4. At last Saturday's ball game, the concession stand sold 20 hot dogs, 40 hamburgers, and 200 soft drinks. What was the ratio of hot dogs and hamburgers sold to the number of soft drinks sold? Okay, so this one is kind of tricky, but you can grasp this really easily. You just got to take it a little slow. So what was the ratio of hot dogs and hamburgers? And is the key there. So that means I'm going to add those two, hot dogs plus hamburgers. So it's 20 hot dogs plus my 40 hamburgers. That gives me a total of 60. So I know the first part of my ratio is 60. Okay. And then next it says hot dogs and hamburgers sold to the number of soft drinks sold. So that's 60 to 200. Okay. But I can reduce this down. I have to ask myself what number is the greatest common factor of 60 and 200. That means the biggest number that can go into 60 and that can also go into 200. And that would be 20. So I'm asking myself, how many 20s can I get out of 60? I can get 3. And then I'm asking myself, how many 20s can I get out of 200? I can get 10. So my ratio here is 3 to 10. All right, let's look at number 5. Number 5 says, Miss Clark divided a bag of 32 chocolate candies between Sammy and Jada. Sammy received 5 pieces of candy for every 3 pieces that Jada received. How many total candies did each student receive? So this one is a tape diagram problem. So I like to label first. So I'm going to label Sammy and Jada. And it told me that the ratio, Sammy received 5, so I'm going to go ahead and make my bar with 5 boxes. And Jada received 3. Okay, and the problem told us that there were a total of 32 candies. So remember, each of these boxes all have the same exact amount in them. So I'm splitting up these 32 candies in 1, 2, 3, 4, 5, 6, 7, 8 boxes. So that means that 4 goes into each box. All right, so now the question says, how many total candies did each student receive? So let's see. Sammy, 4 plus 4 plus 4 plus 4 plus 4. Sammy received 20. And then Jada, 4 plus 4 plus 4, she received 12. All right, number 6. A class of 25 students shared 125 markers. Which statement is true? So they have a couple things for every 5 students. There's 1 marker, 5 students, there are 6 markers. So we're looking at an equivalent ratio here. So I'm going to go ahead and start with A. So I see that my ratio is 25 to 125. So I'm going to compare that to the ratio they gave me for A. 5 students, 1 marker. All right. So I see going from here to here, 125 down to 1, I divide it by 125. So that means if this is equivalent, I must also divide by 125 up here. And I know that 25 divided by 125 is not 5. So A is incorrect. It's not true. Let's look at B. Again, my initial ratio is 25 over 125. And I'm going to set that equal to what's in B. 1 student to 25 markers. Okay? So when I am going from 125 down to 25, I am dividing by 5. So that means up here, I must also divide by 5. If these are equivalent, it'd be correct. 25 divided by 5 is not 1. So B is not true. All right, let's see C. Let's put our initial ratio of 25 to 125. And let's set that equal to 5 students to 6 markers. All right. Let's see up here, I can make an easy jump from 25 down to 5 by dividing by 5. And 125 divided by 5 is not 6. So C is incorrect. Now let's look at D. Now process of elimination means that, of course, all we have left is D. But let's look at this mathematically. Again, our initial ratio is 25 over 125. We're setting it equal to, for every 1 student, there are 5 markers. So let's see. When I go from 125 down to 5, I am dividing by 25. So that means that if this is true, I am going from 25 down to 1 by dividing by 25. And yep, that is correct. So my answer is indeed D.